Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 2, Random Variable and Discrete Probability Distribution, brought to you by Vitan Sir. In my last tutorial, we studied about the binomial probability distribution, its probability density function, that is basically its formula of ncx, p raised to x and q raised to n minus x. Also, we studied what are the dichotomous experiments and the Bernoullian trials based on which we studied the binomial function. So what we are going to do in this tutorial is study illustrations based on those concepts. So I'm going to teach you guys 5 illustrations ranging from number 11 to number 15, which are based on the binomial probability distribution. Starting with illustration number 11. There are 3% defective items in the items produced by a factory. 4 items are selected at random from the items produced. What is the probability that there would not be any defective items among them? So now the question here is that we have 3% defective items. We are selecting 4 items and we have to find the probability that there are 0 defective items. First thing, we need to determine what is our success, then what is the probability of success, and how many items we are selecting, that is P and N. Those are the parameters here. So first we have to recognize the P and N, then we will move forward. Now, event that selected item is defective, I will call it success here. So then the probability of success, that is 3% defective items, that is 3 upon 100, that is 0.03. And we are selecting 4 items, so N will be 4. So my probability of success P is 0.03 and the number of selected items, that is N, is 4. Now out of these N items, we have to find 0 defective items because there are not to be any defective items in the selection. So X will be 0. And as we know that our probability density function is ncx, p raised to x, q raised to n minus x, and we don't have the value of q. So q is 1 minus p, that is 1 minus 0.03, that is 0.97. Now we will put this value into our probability density function, in which I will replace the values of n, c and x. N is 4, c 0 because x is 0, so p raised to 0 and q raised to 4 minus 0. Okay, I am putting the values here. Now we know that for c 0 is 1, anything raised to 0 is also 1, so p raised to 0 will be 1, and q is 0.97, so 0.97 raised to 4, and your answer here will be 0.885. The final answer is 0.89, the round figure answer, of course. So the probability of getting no defective items among all the 4 items is 0.89. So this is your answer, my dear students. It's actually a very easy concept because you just have to put the formula in the question, that's all. Moving on to the 12th one. Probability that a person living in the city is non-vegetarian is 0.2. Poor animals. Find the probability that at the most 2 persons out of 6 persons randomly selected out of the city are non-vegetarian. Okay, now the question here, we have to find the non-vegetarian probability here. So the probability that a person living in the city is non-vegetarian is 0.2. So the event of success here is selecting a person who is a non-vegetarian. So the probability of non-vegetarian is 0.2. So the probability of success P will be 0.2. And then we have to find the probability that we must select at the most 2 out of 6 persons. So the total number of persons which we are selecting here are 6, and we have to select at the most 2 persons out of them, that means maximum 2 or less. So capital X here will be 0, 1 or 2. So it is either 0 or 1 or 2, it can be one of the these three values, and we know from our previous chapter that if or comes, we add. So we have to add the probabilities of getting 0, 1 and 2 persons. We have the values of p and n, so q will be 1 minus p, that is 1 minus zero point 0.2, that is 0.8. So success is 0.2, failure is 0.8, total number of people are 6, and we have to find probability for 0, 1 and 2. So I will start by writing down the probabilities here, and cx, p raised to x, q raised to n minus x, where x is less than or equal to 2, that is 0 plus 1 plus 2. So I will put the equation for each and every of this value. If I take it for 0, it is 6 is 0, p raised to 0, q raised to 6 minus 0. If I take it for 1, it is 61, p raised to 1, q raised to 6 minus 1. And if it is for 2, it is 62, p raised to 2, q raised to 6 minus 2. I will simplify this. 60 is 1, p raised to 0 is 1, q raised to 6 minus 0, that is 0.8 raised to 6. 61 is 6, p raised to 1 is 0.2 raised to 1, and 6 minus 1 is 5, so 0.8 raised to 5. 62 is 6 pi is 30 divided by 2, 15, 0.2 raised to 2, and 0.8 raised to 6 minus 2, that is 4. So next, 0.8 raised to 6 is 0.2621. 6 into zero point 0.2 into 0.8 raised to 5 is 0.3277. 15 into 0.2 raised to 2 is 0.04, and 0.8 raised to 4 is 0.4096. So first we will multiply these values. So we will get 0.2621, 0.39324 and 0.24576, and when we add them up, we get 0.9011. So the probability that the selected out of the 6 persons, at the most 2 persons will be non-vegetarian, at the most will be 0.9011. That means the remaining will be vegetarian. That's a good probability. Moving on to illustration 13. The mean and variance of a binomial distribution are 3.9 and 2.73 respectively. We have to find the number of Bernoullian trials conducted on this distribution and write px. Now, let me clarify one thing. Mean and variance of the binomial distribution are 3.9 and 2.73. That means variance is NPQ is equal to 2.73. I think I have already explained the characteristics of the binomial distribution, in which variance was NPQ and mean was NP. And the third thing which I told you guys, that Bernoullian trials are n, which we are supposed to calculate first. Now, one of the characteristic was that Q is variance upon mean, that is 2.73 upon 3.9 is 0.7. So always remember this concept, variance upon mean is Q, that is 0.7, and if we have Q, we can calculate P, that is 1 minus Q, 1 minus 0.7, 0.3. Now if we have P, we can actually calculate N. How? N is just NP upon P, right? You can cancel the P's and you will get just N. So NP is 3.9 and P is 0.3. So your answer is 13. So first question, Bernoullian trials, that is N, are 13, and we have to write the value of Px. So Px is NCx into Px into Q raised to n minus x. So N is 13, x of course we don't know. P is 0.3, Q is 0.7. So just put the values there. You will get 13cx, 0.3 raised to x, and 0.7 raised to 13 minus x. So that is your px value. You don't know the value of x here, but you know the remaining values, so you just put them there. Now if I want to calculate, for example, 0 or 1 or 2 or 13, I will just put those values in the place of x, and immediately I will get my answers. So this is called finding the px for the given distribution. You write down all the values except the value of x in the equation, and you keep it as it is. So we found Bernoullian trials and using the variance and the mean, and we also calculated the px. Now this is a pretty famous question, one of the favorites of the examiners in your board exams. So study this question very carefully. Okay, moving on to illustration 14. Illustration 14. During a war, average 1 out of 9 ships got sunk during a certain voyage. Find the probability that exactly 5 out of a convoy of 6 ships will arrive safely. Okay, now the first line of this question gives you the probability of success, and the second line of this question gives you the question. Let's see. Event that ship will arrive safely, because that's what it is asked in the second line, can be taken as a success. Therefore, the probability of ship which sinks will be the failure. So the question in the question, 1 out of 9 ships is given as the probability of failure, that is q, that is 1 upon 9. So don't take it as n, it is actually q. Now we want ships to arrive safely, that's our success. So the ships which don't arrive safely are our failures. So the 1 out of 9 is actually 1 upon 9, that is the probability of failure, that ships don't arrive, they sink. So q is 1 upon 9, and then what we are supposed to calculate, 5 out of 6 arrives safely. So 6 is the total number of ships and 5 will be the value of x. So we need exactly 5 ships to arrive safely. Therefore, capital X will be 5. And because we have the value of Q, we don't have the value of P here. P will be 1 minus Q, that is 1 minus 1 upon 9, that is 8 upon 9. Okay. Let's put these values into our equation here. So we need to calculate P5, that is 65 P raised to 5 Q raised to 6 minus 5. Now 65 is 6 and P raised to 5 is of course 8 upon 9 raised to 5, because that's the probability of success, and Q is 1 upon 9 raised to 1. So 6 into 8 raised to 5 upon 9 raised to 5, that is the 32768 upon 59049 into 1 upon 9. Now just simplify these values. Okay, and when you simplify these values you get something like this, 0.37. So that's your probability that 5 ships out of a convoy of 6 ships will arrive safely. Okay, that is 0.37. Moving on to the last illustration, but which is also the longest one. Assume that on an average, one line out of 4 telephone lines remain busy between 2 p.m. and 3 p.m. on weekdays. We have to find the probability that out of 6 randomly selected telephone lines, number 1, not more than 3, and number 2, at least 3 of them will be busy. Now here we have to calculate the probability that the telephone lines are busy. Okay, that's our question here, that the telephone lines remain busy. So the probability of success, that is 1 out of 4 telephone lines remain busy, is 1 upon 4, that is 0.25. In our question we are selecting 6 telephone lines, so capital small n is 6. Now the probability of failure, that is line does not remain busy, will be q, that is 1 minus p, that is 1 minus 1 upon 4, that is 3 upon 4, equal to 0.75. So I have taken both fractions and the decimal values here. You can use whichever value you feel like in the equation. I personally use the fractional values because they give us the accurate answers without the round figuring. But if you guys feel like using decimal values, be my guest and use them. Now the X will be the number of telephone lines which are busy during this time period of 2 p.m. to 3 p.m. Now in the first question, not more than 3. So the event that not more than 3 means it is actually 3 or less. So we will take it as X less than or equal to 3. That will be the first question probability which we will be calculating. And for the second event, at least 3, that means 3 or more. So we can take it as P x greater than equal to 3. So we have to calculate two probabilities. Let's start with the first one. Not more than 3, that means maximum 3 or less. Write down the formula here. Now x is less than equal to 3, that is 0, 1, 2 or 3. Now never wonder why 0 is there, because 0 is always there unless and until it cannot be there. Put the value here. Now because we are taking 0 here, it will be 60 p raised to 0 q raised to 6 minus 0. For 1 it is 61 p raised to 1 q raised to 6 minus 1. Similarly for 2 and 3 values. Now, as I simplified step by step, be very careful and do it with a lot of patience because it requires your patience and nothing else. Now, 60 is 1, p raised to 0 is also 1, q raised to 6 minus 0 is actually 3 upon 4 raised to 6 because q is 3 upon 4. 61 is 6, p raised to 1 is 1 upon 4 raised to 1, and q raised to 6 minus 1 is 3 upon 4 raised to 5. 62 is 15, p raised to 2 is 1 upon 4 raised to 2, q raised to 6 minus 2 is 3 upon 4 raised to 4. 63 is 20, p raised to 3 is 1 upon 4 raised to 3, and q raised to 6 minus 3 is 3 upon 4 raised to 3. Okay, now again you have to solve it one by one. For the first statement, 1 we can just ignore them. 3 raised to 6 is 729, 4 raised to 6 is 4096, so just write that down. Next we have to go step by step. 6 will be 6, 1 upon 4 raised to 1 will be 1 upon 4, 3 upon 4 raised to 5 will be 3 raised to 5 243, 4 raised to 5 1024, plus 15 will be 15, 1 upon 4 raised to 2 is 1 square 1, 4 square 16, 3 raised to 4 81, 4 raised to 4 256, plus 20 remains as 20. 4 cube is 4 4s are 16, 4s are 64. 3 raised to 3 is 27, and 4 raised to 3 is again 64. Now just multiply all the respective values. So 729 upon 4096 plus 1458 upon 4096 plus 1215 upon 4096 plus 540 upon 4096, and when you add up all the numerators, because the denominator is the same, you get 3942 upon 4096, and your final answer here will be 0.9624. So the probability that no more than 3 telephone lines will be busy out of the 6 telephone lines is 0.9624. I hope you guys got it properly. Else we still have one more question left. That's the second question. At least 3 lines will be busy. That is, when we say at least 3 lines, it is x which is more than or equal to 3. So it is either 3 or 4 or 5 or 6. So this time 3 will be common, but I am going to write it anyways, and then we have to find 4, 5 and 6. So 63 p raised to 3 q raised to 6 minus 3 plus 64 p raised to 4 q raised to 6 minus 4 plus 65 p raised to 5 q raised to 6 minus 5 plus 66 p raised to 6 q raised to 6 minus 6. So moving on, 63 is 20, p raised to 3 is 1 upon 4 raised to 3, q raised to 6 minus 3 is 3 upon 4 raised to 3, plus 64 is 15, p4 is 1 upon 4 raised to 4 into 3 upon 4 raised to 2, plus 6 into 1 upon 4 raised to 5 into 3 upon 4 raised to 1, plus 66 is 1, p raised to 6 is 1 upon 4 raised to 6, and q raised to 6 minus 6 is actually raised to 0. 6 minus 6 is 0, and anything raised to 0 is 1. Okay, now open the brackets here quickly. 20 into 1 upon 4 raised to 3 is 1 upon 64, and 3 upon 4 raised to 3 is 27 upon 64, just like the previous question. Of course, that's common. 15 remains 15, 1 upon 4 raised to 4 is 1 upon 256, and 3 upon 4 raised to 2 is 3 square 9, 4 square 16, plus 6 into 1 upon 4 raised to 5, so 1 raised to 5 is 1, 4 raised to 5 is 1024, 3 upon 4 raised to 1 is just 3 upon 4, plus, now 1 we can just forget about them, 1 upon 4 raised to 6 is 1 upon 4096. Just multiply the respective values wherever it is possible. Ignore the additions right now because multiplication comes first, and then because all the denominators are the same, add the numerators. You get 694 upon 4096, and your answer will be 0.1694. So the probability that at least 3 telephone lines remain busy, that means 3 or 4 or 5 or 6 telephone lines remain busy, is 0.1694. Okay guys, so with this I end my tutorial here. Next time I will do the remaining next 5 illustrations, that is illustrations from 16 to 20, and I will come forward with the same binomial type examples. I told you in my previous tutorial that because the exercise for this binomial only contains 5 or 6 questions, I'm taking the illustrations to explain it right now, else you can learn the illustrations on your own because they are quite easy. Actually, the main problem is solving the exercise questions. Anyways, thank you for watching my tutorial. In case of any doubts or queries or questions, you can comment in the comment section below. You can contact me on my WhatsApp number given in my contact details at the end. Don't forget to watch that, subscribe my channel, like my video, share it to your friends, and let me know what you think about it. See you in the next video. Thank you. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.